Good morning. Welcome to another edition of Chemistry on the Fly with Mr. Af. We're going to talk about balancing equations again, and it's going to be 5.55, and this is part 2 of our two-part series. Okay, we talked about balancing equations. There's a bunch of steps that we take. So the first step is going to be drawing a line separating our products from our reactants. Then we're going to identify what elements we're dealing with in this reaction. Then we're going to figure out what our starting quantities are. Then we're going to check and see if we're balanced. That's going to be a predominant question. Are we balanced? Then, most of the time we're not going to be balanced, but there are going to be times that we will. So then we have to look at changing or multiplying by our coefficients. And then we need to check and see if we're balanced again. And then, if not, we have to redo our steps. So, this does have some issues. Okay, one of the things that we always have to remember to do is to, and Ross, remind us what that is. Thank you. It's going to be practice, practice, practice. This does take a lot of practice. So let's get started today. Before that, we've got to get some balancing tips. So we've got two that we've already learned. So the first one said that we will treat polyatomic ions as elements. So if we have anything in parentheses, we're going to treat that just like an element, just like we would treat a hydrogen or a carbon or something else. We're going to treat our polyatomic ions, and again, they'll be in parentheses, as complete elements. All right, the next thing is that we're going to save our oxygens for last. Now, we haven't seen that yet, and we probably won't even see it today, but in the future we will. The next one, this is a new one for us. We have to remember that the coefficients and the subscripts need to be whole numbers. Now, this is really more like a law than a tip, but we still have to pay attention to it. So I put it in the tips column this time. Now, what this means is that I can't have like a half of a carbon or a half of an oxygen molecule or a half of a glucose molecule or anything, or any fraction for that matter, of anything. I have to have it as a whole. It's either going to be one carbon atom, two carbon atoms. It's not going to be 2.6 or 2.8 carbon atoms. I just can't do that. We can split atoms now. However, doesn't happen in nature. We can spin things really fast and fire them and break atoms into little pieces, but that's really expensive, and it's not something that happens in nature, as I just said. So that's one of our new balancing tips. The next one, this one's also another balancing tip. If two elements are in the same compound, actually if I have two elements of the same thing in the same compound, and we have to count them together. So this is an example, CH3OH. This happens to be methanol. So CH3 is the meth, and then OH is going to tell us it's an alcohol. So some people call this methyl alcohol. And that CH3, notice that I have CH3 and then I have an OH at the end. So that is going to mean that I have 4 hydrogens, and we'll treat it as though there are 4 hydrogens in this compound. And that's all we're going to learn for today. There are some more, so notice I have some space at the bottom. We're going to pick those up at a later date. All right, so let's jump into balancing equations. This particular one is going to be a decomposition. So I have sugar, table sugar, C12H22O11, and it's going to break down into just pretty basic stuff of carbon and water. So this is, again, table sugar. It's called sucrose, and we're going to learn about sucrose a little bit later. All right, but let's follow our steps. So here's our first step, is to draw a line down the middle. Okay, so we're separating our reactants from our products, and we write down our elements. So I have CHO on the reactant side, and we're going to put them in the same order on the product side. Now, one of the things that I was thinking about, you might want to be writing this stuff down and to see how we actually do it. So it might be worthwhile to get a piece of paper out and write this down. And even pause the video if you want to catch up, because this is something that Ross told us already. We're going to need a lot of practice, and it's going to be doing it by hand. So we have our CHO on both sides. Now we've got to identify our quantities. So I'm going to bring up our quantities. So 12, 22, and 11. let's see where those come from. So in the sucrose, I have carbon 12. Okay, I have hydrogen of 22, and I have oxygen as 11. So those are our numbers on the reactant side. On the product side, I have our numbers of 1, 2, and 1, and that's going to be my carbon, 1 there. I have 2 from my water, 2 hydrogens from my water, and 1 oxygen from my water. So that's where we are. Now the first thing we're going to do is we're going to see if they're balanced. No. Why do you say that, Chandler? Not sure. Are you really sure? No. Okay, so what do we got to do? Let's check. All right, so our carbons, 12 to 1. Chandler's probably right on this. Okay, hydrogen, 22 to 2, and oxygen is 11 to 1. So Chandler was right on that one. All right, so the next thing we have to do after checking our balance on number 4, we've got to go to number 5, and we've got to change our coefficients. So let's look at that. We'll get rid of those boxes, and let's check. So I have carbon 1 on the product side and 12 of them on the reactant side. So I'm going to have to multiply the carbons by 12. So I'm going to take this 12 here and multiply or add it to the top up here. So this is saying that I have 12 carbons. Sounds good. All right, while we're here, we also notice that our hydrogen and our oxygen are not balanced. So let's look at balancing our hydrogen first. So we have hydrogen at 2 and the going to 22. So what I'm going to need to do is multiply the hydrogen by 11. So there's my 11. We're going to put it up top. We're going to circle it. And notice that this 11 belongs to the hydrogen as well as the oxygen. So I need to make sure that I multiply the oxygen by 11 as well. So that will be good. Now, let's see. Please be right, Rachel. Okay, well, let's check. Okay, we'll check and see if it's right. Okay. All right, we'll see ya. All right, we got to check and see if we're balanced. So my carbons are good. We've got our hydrogens, they are good. And our oxygens, they are good. And we've got a new visitor today, it looks like. Monica, thanks for telling us. We did get this. So we did get that. Nice job. All right. Thanks for showing up, Monica. We missed you the other day. All right, let's look at another one. This one's going to be a double replacement. So I have calcium fluoride plus hydrogen sulfate, and it's going to react, and I'm going to get calcium sulfate and hydrogen fluoride. So this is a double replacement. Notice that I have 2 couples on each side. Okay, so let's go through our steps, draw the line. We're going to identify our elements. This time I have 4 elements. I have calcium, fluorine, hydrogen, and sulfate. Now, this is one where I told you that we're going to treat the sulfate as first of all, it's a polyatomic ion, and we're going to treat it as an element. That's one of our first tips. So we have that. We're writing it down just like we see it. Okay, I'm not worried about how many sulfurs I have, not how many oxygens I have. I'm just going to realize how many sulfates I have. So we're going to put the same list on the other side in the same order, so it's easier to check. Okay, the next thing we're going to do is identify the quantities. So I've got 1, 2, 2, and 1. Let's see where these guys come from. So I have calcium of 1, fluorine of 2, hydrogen of 2, and the sulfate just has 1. Okay, let's look at on the product side. So I have 1, 1, 1, 1. So where all the ones come from? Calcium has 1, the fluorine has 1, the hydrogen has 1, and the sulfate has 1. All right, so we're going to check and see if they're balanced. And let's see. We've got our calciums are good, fluorines are not good, hydrogens are not good, and the sulfates are good. But Joey's coming back to tell us that nope, we're not balanced. We have to have all 4 of them balanced. All right, Joey, thank you. See you later. All right. So the next step is we have to look at is our coefficients. Okay, so we have fluorine on the product side is 1 and fluorine of 2 on the reactant side. So let's look at this. Putting a 2 there, we're going to take a 2 and we're going to put it right next to the hydrogen fluoride. Okay, we're going to take that 2 and we're going to put it down with the hydrogen. Since it's hydrogen fluoride, we've got to multiply both of them by 2. And then we're going to wait for it. Wait for it. Guess what? We're going to have to check and see if it's balanced again. Thanks, Ross. All right, let's see what we've got. Calcium, calcium. Check. Fluorine, fluorine. Check. Hydrogen, hydrogen. Check. Sulfate, sulfate. Check. And yes, we are balanced. Very good. All right, so that's 2 of the 3 we're going to practice with. Let's look at, thanks, Phoebe. Let's look at a new one. This one's going to be a single replacement. So I have aluminum plus copper chloride is going to react, and we're going to have aluminum chloride and copper. So this one is a single replacement. So let's look at our steps. This one's going to offer a little bit more of a challenge to us, and we'll see it in a little bit. All right, so first of all, we're going to draw a line. We're going to ID my elements. Okay, aluminum, copper, and chlorine. Aluminum, copper, and chlorine. Okay, we're going to identify our quantities. Aluminum 1, 1, 2. So it's 1 for aluminum. Copper is 1. Chlorine is 2. Let's look at the product side. We got 1, 1, 3. So aluminum. We've got 1 copper. And we have 3 chlorines. Now, here's where our struggle is. Okay, let's check and see if we're balanced first. That's what our step 4 is. We got good for aluminum and chloride, or copper, but our chlorines are not matching. So we're not balanced. Oh, sorry for bothering you, Monica. Yeah, really. Yeah, sorry. You can go back to reading your paper. Thanks. All right, so here's our little challenge. We have 2 and a 3. So a 2 and a 3, they can't go into each other. 3 doesn't go into 2 evenly, 2 doesn't go into 3 evenly. So we're going to find a common value that they both go into. So we've done this in math class, so we're going to realize that I can multiply 2 by 3 to get 6. And on the product side, I can multiply 3 by 2 to get 6 as well. So I have 2 6s for my chlorines. So let's check and see what that looks like. So I'm going to take a 3, put it up with a copper chloride. Then that 3 also is going to have to go to the copper. So we're going to multiply the copper by 3 as well. Then I have a 2 on the product side, and we're going to put a 2 with the aluminum chloride. And we're going to have to multiply the aluminum by 2. All right. So let's see. Are we balanced? No, sorry, not yet, Rachel. Sorry about that. All right, have a good day. Goodbye. All right, so we're getting close. But we just need to figure out a couple things. So we look at our aluminum is 1 and we got 2. Okay, copper is 3 and 1, and chlorines do match. We just match those up or balance those. So let's see what we can do here. So we're going to multiply our aluminum by 2 to get a 2. So we're going to take our 2 and put a 2 on the top, and now aluminum's balanced. Now we have to do the same thing for copper. So we have to multiply the copper side by 3, or the product side by 3 for the copper, and we can then get that to balance. All right, so it looks like we've got this all balanced, and bazinga, Sheldon, what are you doing here? I know we're friends, but this is an air quotes friends gathering. I'm not sure you really belong here. Why don't you go in your own video, Fun with Flags, which you never invite me to, but that's another story. See you later, Sheldon. Goodbye. All right, so we are balanced. Sorry about that. We are balanced, but we need to just make sure everybody's good. So we're going to go through our steps again, and then we're going to call it a day. All right, so the steps, we have draw the line, ID the elements, ID the quantity. We're going to make sure they're balanced. If not, I have to change some coefficients. We check and balance again and keep on going. And what do, Ross? We practice, practice, practice. All right, guys, that's all we've got for this episode of Chemistry on the Fly. and with Mr. Af. And as always, have a